So let's look at some practice. Which of the following combinations of quantum numbers are allowed? Okay, now we notice there's only 3 quantum numbers here. Spin is not here, and that's because whether something's allowed or not has to do with this hierarchy depending on what value of n, which determines the allowed values of L, which then determines the allowed values of ML. So if n equals 1, can L equal 1? Well, remember that L can have any value from 0 up to n minus 1. So this is not n minus 1, this is n itself. So we don't have to go any further at this point. Since our L value is not allowed, this is not allowed. All right, let's look at the second one. N equals 3, L equals 0. That's possible because when n equals 3, L can be any value from 0 up to n minus 1, which would be 2 in this case. So this is allowed. Is our ML value allowed? Well, we remember that ML can be any value from negative L to positive L and all the integers in between. So yes, if L equals 0, then ML can be 0. In fact, it's the only value that ML can be. So this is allowed. So let's think about what this means. This means we're in our third energy level, or our third shell. L equals 0 is the S subshell, and this is the one orbital that's allowed in that S subshell. All right, let's look at n equals 1, that's allowed. L equals 0, that's allowed. But if L equals 0, then ML cannot be negative 1. If L equals 0, then ML equals 0 is the only value that ML can be. So this is not allowed. All right, let's look. The next one, n equals 2, that's allowed. L equals 1, that's allowed, because L can be any value from 0 up to n minus 1, so this is allowed. But ML is only from negative L to positive L. So if L equals 1, that would only be negative 1, 0, and 1. So ML cannot be 2, so this is not allowed.